Hey everyone, so today we'll do a question named product of array except self. So let's first understand what this question is saying. So we have been given a array nums, right? And what we have to do, we have to find the product of all the elements of the nums except the number itself on that position. So to make it more clear, let's take this example of 1 comma 2 comma 3 comma 4 and it so let's do the indices as well, 0 1 2 and 3. So if I want to know the answer on the 0th index, so what will be the answer? Product of all the elements except the element on the 0th index. So what do we mean by that? So if I want answer on this position, so I have to ignore this element on this 0th position, right, and multiply all the numbers which left. So 2, 3 and 4 is left, right? Now I have to multiply this and I'll get the answer on this position. Okay, so the answer would be 2 into 3 into 4, which is 24, right? Similarly, now if I want the output at this position, so I have to ignore this element. That is, if I want to find the output on indices 1, then ignore the element on the indices 1 and multiply all the elements which are left. So which are left is 1, 3 and 4. So 1 into 3, 3 into 4 is 12. So answer would be yes, 12. Now similarly with the indices 2, ignore the element on the indices 2. Now ignore the element on indices 2 and multiply these elements. So elements would be 1 into 2 into 4. Yes, the answer would be 8, right? 8. And if I go on indices 3, ignore the element on indices 3 and multiply all the elements which are left, which is 1, 2 and 3. So answer would be 1 into 2 into 3, which is 6, right? I hope now you'll understand the question, right? Now see what all are the conditions which this question is telling us and come up with the algorithm. So this question is telling us that we must write an algorithm in O of n time. That is, we have to write this algorithm in linear time, and we are not allowed to use this division operation. Okay, so we don't have to use division operation and have this algorithm in linear time. Okay, so let's jump on the algorithm and let's find the intuition of it. So let's take an example of nums, which is 1 comma 2 comma 3 comma 4 comma 5 comma 6. Okay, comma 6. Let me add the indices as well. So 1 is on index 0, 2 is on index 1, 3 is on index 2, 4 is on index 3, 5 on index 4 and 6 on index 5, right? Now we have to come up with the answer array, right? We have to come up with the answer array, and the answer array is per the question is that product of all the elements except the element at the ith position. So if I am on the 0th index, I have to ignore the element on the 0th index and multiply all the elements. So if I talk about this, I have to multiply if all the elements except the 0th index. So these are the elements and I have to ignore the 0th element, right? Okay, so how to solve this? So think it like this. If I want the product at index 3, so what I'll do, what I'll need, I'll need product of all the elements on the right side and product of all the elements on left side, right? If I have these, that is right product and left product, I'll repeat myself. If I have left product, that is product of all the elements on the left side of the index 3 and product of all the elements on the right side of the index 3, then I'll know what I have to do, right? Do you understand what we have to do? Yes, we have to multiply left product and right product and we'll get our answer. To make it more clear, so left product would be 1 into 2 into 3 would be 6 and 5 into 6 will be 30. If I multiply these two numbers, 6 into 30, it will give me 180, and this is the element at this position. If we multiply this, 1 into 1 into 2, 2, 2 into 3, 6, 6 into 5, how much? We have to ignore 4, right? 6 into 5, 30, and 30 into 6, 180, and that is 180, right? So we get it. So answer of I equals to left product of I into right product of I, right? So we get the formula for getting the answer. But now you think, hey, we get the answer formula, but how to find this left product and right product, and we are not allowed to use the divisions, right? So now let's talk about the left product. Okay, left product. So first of all, what is left product? Left product is the product of all the elements left to the position which we are currently on. So if I want to find the product of all the elements on the left side on which I am currently on, how I found it? So let's talk about an example nums, which is 1, 2, 3, 4, 5, 6, right? Now let's add indices as well. 0, 1, 2, 3, 4 and 5. Now let's talk about this position, that is on index 3. I want to find out all the number, all the product of all the elements on the left of the 3, right? So how to do that? So if I know the left product of this index, then I can easily find the left product of this 3 index. What I'm trying to say is, if I know the left product of second index, then I can find the product of the third index. How? Easy peasy. It is 3 into left product of whatever is the left product of 2, right? If I multiply 3 with the left product of 2, then I'll get the left product of 3, right? LP of 3. Didn't understand it? Let me explain it one more time. Okay. Now I want to have the product of all the elements on the left of fourth index. So now I already know the left product of 3, which is 3 into left product of 2, which is 1 into 2, which is equals to 6. So how I'll find out the left product of all the I found out LP4, that is product of all the elements left side of index 4. So I already know 3. I just have to multiply the number of index 3 with the left product of 3. Okay, so it is 4 into left product of 3, which is 4 into 6, 24. So if I go 1 into 2, 2, 2 into 3, 6, 6 into 4, 24. Easy peasy. So we know the formula of LP now. So LP of I equals to nums of I minus 1 into LP of I minus 1. But now you're thinking, hey, but we don't know how LP of 0, right? LP of 0 or LP of 0 minus 1. So if we don't have anything on left, the LP of 0 will always be 1 only, right? Because we don't have any left product of any elements. We don't have any elements left to the 0th index, so LP of 0 will always be 1. So now let's talk about the right product. Right product. So for right product, it is similar to the left product, only one change, that now we have to traverse through right to left, right? So RP of 5, we always know that it is 1 only, right? Because there is no elements right to the index 5. 5 is the last, 5 index is the last of our nums, so no element right side to this index, so RP of 5 will always be 1. Now if we want to find out what is the right product of this index, that is product of all the elements right to the index 3, that is RP3, then we know it is 5 multiplied by right product of at index 4. So all the product of the elements right to the 4 into the number at 4, right? This is similar to left product. So now we have the formula of RP as well. So RP of I equals to nums of I plus 1 into nums into right product of I plus 1. So we get all the three formulas. Let's write here only. So RP of I equals to nums of I plus 1 into RP of I plus 1, right? LP of I equals to nums of I minus 1 into LP of I minus 1, and answer of I equals to LP of I into RP of I, right? So now we have these three formulas in our hand. Now let's jump onto the code and see if it is working or not. So now we have all the formulas in our hand, and let's see code, right? So in code you can see that I have two arrays, left product and right product, which is initialized to 1 into length of nums. So we are doing this because of we know that initially the LP0 and RP of last of nums will be 1 only, right? So we are just doing for the sake of that. Now we know the left LP of I formula, nums of I minus 1. This is same what it is, right? And same goes for right product. The only catch here is we are iterating left to right for left product and right to left for right product. Once we get the left product and right product, we are just calculating the answer in the result, that is left product I into right product of I, and then returning the result, and it will solve your problem. So thank you for watching and subscribe for more. Thank you.